I'd like to talk to you a bit about NVIDIA platforms and how they come together on the Oracle Cloud Infrastructure. I will be joined shortly by my friend Leo Leung from Oracle, who will talk more about some of the specific Oracle solutions on the Oracle side. But what I'd like to first talk to you about is some of the important aspects of the NVIDIA platform. And it's important to think about what we do at NVIDIA as a platform, right? You know, we sometimes are thought of as those guys who make GPUs, but we are in fact a platform company. And if you think about what's been going on with AI, and in particular, thinking about generative AI, which has really been the thing that has just really excited so many markets beyond what we think of as sort of the core technology markets, it's possible to generate so many different kinds of content using generative AI. You know, if we think about the first 10 years of deep learning, in a lot of ways, that was really more about recognition of images, recognition of text, and then that slowly made its way into natural language understanding, which ultimately brought us to things like large language models. And that has just been something that has just opened up just an amazing sort of myriad of possibilities of what can be done with AI. And so we just sort of show here some of the inputs and some of the resultant outputs you can get in terms of generating content with AI. And so, but to enable this takes just an amazing amount of not just cutting edge hardware, but also a tremendous amount of ecosystem enabling, which is something we do here at NVIDIA. This next slide sort of shows you sort of the growth curve that we've been on. And in particular with the advent of the transformer model in 2018, we've just sort of seen, you know, the growth curve in terms of model size and also model complexity. It's important to think about both things because while we generally look at model size as sort of a proxy for its requirements, there's also the matter of, you know, how complex is each layer of that model, right? In terms of, you know, how much compute does it require to generate and train each part of that model and ultimately the entire model, right? And so you can just sort of see here the growth trajectory we've been on has been very aggressive and it really shows no signs of letting up. Right? I mean, you know, in addition to the models we're showing here, more recent models like, you know, Gemini Ultra is at over a half a trillion parameters. Llama version 3.1 is over 400 billion parameters. The models just continue to grow in size. And in addition, what's interesting is even smaller models that are, say, less than 10 billion parameters, one of the techniques that developers are looking to do is to run many more tokens through smaller models to get them to deliver better accuracy that better compares to larger models. And the reason they're doing this is to come up with more cost-effective deployment when they go to deploy the model as an application and it's inferencing, say, 24/7, right? So at NVIDIA, we love to talk about performance, but you know, it's important to understand kind of the why. You know, it's not performance for its own sake. Performance ultimately drives return on investment, right? If you think about how AI works, you know, when you're doing your training of a model, that's the investment you're making in AI. When you deploy your application, when you start inferencing and bringing in new data for that model to work on, that's where you really begin to see your return on investment. And you know, the results can be quite remarkable. And in fact, we've done some estimates that say that about $1 spent doing LLM services can actually generate about $7 of revenue over the course of 4 years. So if you think about, you know, sometimes people refer to this as what they call tokenomics, right? It is kind of an extraordinary thing that these LLMs are just finding their way into so many different use cases, so many different applications, and the fact that there's an opportunity to generate this kind of revenue. So what does it take to actually deliver all of this? And the answer is it takes an entire platform, right? We, NVIDIA, are a data center platform company, right? It's important to understand all the work that we do. And in fact, at NVIDIA, we have twice as many software engineers as hardware engineers. And that's a very purposeful choice, right? It takes a tremendous amount of ecosystem enabling, and you can see just sort of from our high-level diagram here that shows our entire sort of stack. Those things that look like Christmas trees are actually, we sort of tried to map out all the different libraries we have for acceleration. And we have, I think, to date, we have something like over 400 different acceleration libraries to cover just a huge swath of use cases and different types of computational problems. But also, it's important to kind of look across the top of that slide and see some of the different application, essentially frameworks that we make available to the community. The most recent one being NIM, right, which is NVIDIA Inference Microservices, that makes it much, much easier to deploy models that have already been containerized for you. Using pre-trained models, of course, you can fine-tune those models with your own data if you so choose. But the point is that we are continuing to develop software, and then we work in conjunction with partners like Oracle to bring those offerings onto the cloud platforms to make them easy for Oracle Cloud customers to use, right? Okay, let me keep going. So I wanted to just kind of take a little pause here. What you're seeing here, these are some pictures of the Blackwell platform up and running in our data center, right? So sort of action shots, we call them. What you're seeing here on the left-hand side, that's actually NVLink and NVSwitch. There are different trays that will go into the Blackwell system. You can see them in the center console there. And the NVLink switch trays are an integral part of the Blackwell platform, right? And then that right shot is just an engineer hard at work. You know, we sort of was a happy accident in terms of the action shot, the blur, you know, and we sort of joke, you know, that's because we moved that fast, right? But the point is that, you know, we got Blackwell up and running in the lab. We actually recently delivered some phenomenal performance with Blackwell and an industry standard benchmark called MLPerf, and I'll talk about that in just a moment. But another important thing to understand about Blackwell is that Blackwell is a platform. There is a tendency, you know, when you hear NVIDIA code name, you think, okay, well, that's just the next GPU. That's just the beginning, right? Again, it takes an entire platform to do what we do. And as you look across the top of this slide, you see all the different components that may be going into one of these platforms to enable them, right? And so, you know, it starts with the GPU, but from there, you know, we have our great CPUs. The NVLink switch chip is a hugely important component to our platform. The NVLink fabric that allows our GPUs to communicate with each other at incredibly fast speeds. In the Blackwell generation, we'll be able to have up to 72 of those Blackwell GPUs communicating with each other at 1.8 terabytes per second. So this is just us continuing to innovate at the platform and even the data center level to enable that next generation of AI applications, right? And now across the bottom, what you see are some of the different trays that comprise the Blackwell platform. You start with the compute tray, you start with the switch tray on the left, then you have the compute tray, which is what actually houses the GPUs and the CPU. Then of course we have either our Spectrum X800 for Ethernet, which can also of course be used with Rocky, and then our Quantum switching tray, which would be for InfiniBand. Speaking of InfiniBand, I wanted to just spend a minute and talk about NVLink Switch. As I mentioned, we are a platform company, and our GPUs, while they're really kind of the heart and soul of our platform, they're not the entire platform. And in fact, the NVLink Switch chip, as you want to perform at scale, that ability to have the GPUs communicate with each other at very, very fast speeds and at very low latency becomes absolutely essential. Because as you go out to scale, you know, you do incur communication overhead. And so it's very important that that overhead be intelligently managed to enable best scaling, right? So our NVLink switch chip does exactly that. It's an all-to-all solution that allows every GPU to talk to every other GPU. Today that happens at 900 gigabytes per second in the Hopper generation. As we move into Blackwell, we will double that to 1.8 terabytes per second. And in the case of NVLink switch, with how we deploy it in these trays, we actually aggregate that bandwidth with multiple NVLink switch chips for an aggregate bandwidth of 14.4 terabytes per second. So just extraordinary speeds to enable those Blackwell GPUs to communicate with each other. You think of that mostly as a training thing traditionally for things like all reduce and all gather type operations. But increasingly, as we see the inference side continue to grow, and as we see the continued requirement for real-time compute for AI applications, for those powered by LLMs, that combination of big, demanding models plus the need to deliver results in real time is really driving a need for significant compute and scale and inter-GPU communication on the inference side as well. So speaking of that, on a recent round of the MLPerf inference benchmark version 4.1, we actually did our very first submission using Blackwell. And we achieved a 4x speed up versus our previous generation H100 GPU. That part's pretty interesting. What's really interesting is not only was this the first Blackwell submission we ever did, it's the first FP4 submission that was ever done in MLPerf, which means we ran much of this model and about 50% of the compute time was done using FP4 precision. Now, why is that interesting? That's interesting because reduced precision has been a technique used in AI for quite some time. The challenge with it, of course, you know, when you're using reduced precision is quantization, which is to say rounding errors, right? As you reduce precision, you lose accuracy. This can adversely affect your model's ability to deliver accurate answers. So managing that quantization algorithmically becomes an extremely challenging problem. It's something we've been doing for quite some time, actually, with int8, actually, going all the way back to our Pascal generation of products. More recently, we introduced FP8, and now we're going to be introducing FP4 and FP6 in Blackwell. So on this submission, our team was able to actually do the submission using FP4 precision, get that 4x speed up, but more importantly, pass every quality metric in the benchmark for accuracy. So in other words, our accuracy loss was essentially near zero while going to FP4. So you're getting kind of the best of both worlds. You're getting this speed up, but in addition, you're not compromising your accuracy. So while we're talking about LLMs, I want to talk a bit more about multi-GPU. I was just talking a moment ago about communication overhead and the importance of making sure that you are able to have the GPUs talk to each other very, very quickly and not let communications become your bottleneck. We're showing two animated images here showing different token rates per user from an LLM chatbot. Right? Just to give you an example, kind of what they look like and how they feel. Right? If you think about it, if you've interacted with ChatGPT or Perplexity or any one of the chatbots, you'll know that the moment you hit enter, there's going to be maybe a slight pause, and then the answer starts coming in. Generally speaking, you want the answer to come in at a minimum of 50 tokens per second. 50 tokens per second is about 50 words per second. Not quite. It's probably 40 something. We think it takes about 1.2 to 1.5 tokens to represent a single word, right? But in order for this to come in smoothly at this rate, so we generally deem that about 50 tokens per second per user is a good rate to come in, because that allows you to not only read sort of sequentially, but if you want to scan ahead or if you want to just do a quick scan of what the answer is, you can get to that faster, right? And so we've been looking at ways, okay, well, how can we make sure that we're delivering a really good number of tokens per second per user while also getting best performance out of our platform, because sometimes those two things pull at each other a little bit. In other words, the more you try to increase tokens per second per user, you will sometimes compromise your ability to get maximum throughput from a GPU, because you're also dealing with latency issues and things along those lines. So one of the key enablers that helps us deliver multi-GPU inference, and this is an example we gave on Llama 2 70B, excuse me, Llama 3.1 70B, this is on our H200 GPU, is that we're able to get up to 50% more performance thanks to using the NVSwitch technology that's on the Hopper platform, right? And I talked about that a few minutes ago. This allows all 8 GPUs to talk to each other all to all, 900 gigabytes per second, right? So what we want to show here is that while the GPUs obviously are a huge driver of the performance gains that we've been getting out of our platform as we move through time, it's not the only thing that helps us drive more performance. The NVLink switch has a super important role to play, not only for training, but also for inference. So along the lines of getting more performance from our platform, one of the things we've been able to show is that we are continually upgrading, optimizing, making our software better that we publish every month in containerized form on our NGC website. It's also available through NVIDIA AI Enterprise and is available through the Oracle Cloud Marketplace. So even in just the 6 months between rounds of ML Perf, we were able to get up to 27% more performance on the very same hardware. So what that really means for an end customer is an investment you make on the NVIDIA platform means you will get great performance today, you will get even better performance tomorrow. Typically, in any generation of our GPUs, over the life cycle of that GPU, we will typically get anywhere between 2 to 2.5x more performance from ongoing software optimizations. And this is something that we just do as a way, because we know that there's this concept that we have at NVIDIA called speed of light. And our goal always is to take our platforms and get them to what we call speed of light, basically making them all that they can be, right? And so this is one example of how we've been able to do that. And a lot of the work that we do for ML Perf, that we do for submissions, we've been submitting to this benchmark since its inception in 2018, also finds its way into our production software, our production containers, our NVIDIA AI Enterprise containers, et cetera, so that, again, the performance benefits that we're getting here do make their way into the software that's being used sort of out of the box, right? And so another area I want to just touch on briefly in terms of ways we improve software. So if you're familiar with large language models, you've heard of Llama 3.1. One of the remarkable things about this one is it was dramatically grown in terms of its size from its predecessor, which was at 70 billion parameters. This one goes to 405, right? So more than 5x is the number of parameters. What we wanted to show here is that even in the course of just a single month since the time that LLM came into the market, we've been able to do optimization work on it to get its performance to increase by up to 44%, right? And this is something that we just, again, are doing on a rolling basis. We work very closely with we're the only AI company that works with every other AI company, right? And we work with all of these developers building these state-of-the-art language models to make sure that they get great performance on the NVIDIA platform, that day zero support is there, not only just in general, but even using our NIM program that I talked about a few minutes ago. And that, again, we are on an ongoing basis continuing to tune these models, again, to get the most out of them and then bring that to the community so that as they deploy these models, they're getting their best performance on the NVIDIA platform. So how does that then translate into how we work with Oracle? So you might think, well, okay, NVIDIA GPUs, Oracle has them in their cloud. That is a true statement as far as it goes, but it's just the beginning. So what I wanted to show you here, this is a bit of an eye chart, but it goes to giving you a sense of scope of how much collaborative work we do together, right? I mean, you see the GPUs up here in the upper left-hand corner, but as I talked about before, that's just the beginning, right? You know, we go through, again, we work with networking. Oracle has been using our network interface cards, our NICs, our CX7 NICs. And then as we move over here into Sovereign, we're working together with Oracle here as well to enable Sovereign for a number of countries and a number of governmental agencies. Leo's going to talk a bit more about that when he comes on stage in just a few minutes. And then, of course, we're constantly integrating NVIDIA technologies into the Oracle platform, right? Some of the ones I want to at least draw your attention to today are around database. You know, as you may or may not know, Oracle makes a pretty good database. And we're very excited to see that Oracle, through collaborative work we have done with them, is doing demos of a couple of newer databases that are using spatial and graph database techniques that will be GPU accelerated, right? That'll be demoed here at Oracle Cloud World. And in addition, for Autonomous Database, which is sort of the main sort of database product, there will be acceleration available through the Oracle machine learning notebooks. And again, this is something that's being demoed here at the show. So these are just some great innovations that will help bring just huge stores of data that live in Oracle databases and bring them into generative AI. Because ultimately, data is sort of the lifeblood of AI. It's what we use to make AI smart, right? And so that ability to bring that data from Oracle databases into generative AI is going to unlock just a whole other realm of possibilities as to what Gen AI can do, right? And then lastly, just in terms of the marketplace solutions here, there's DGX Cloud, which is a service NVIDIA offers. Oracle Cloud was one of the very first platforms to have that. Our NVIDIA AI Enterprise support program, also available, that has secure, scanned, containerized software made available to Oracle Cloud customers with support from NVIDIA. I mentioned NIM earlier. A lot of good work going on with NIM for both bare metal as well as the VM instances using the Oracle Kubernetes engine. And then for visual compute, there's NVIDIA RTX Virtual Workstation for those who want to have virtualized workstation, where you can basically be getting desktop workstation sort of power in terms of your discrete graphics in your laptop and take it anywhere, right? Because the horsepower is living in the cloud. And then things like Clara Parabricks for healthcare, right? So there's this just incredible scope of collaborative work that we do together to make the NVIDIA and Oracle platforms come together and offer just a great set of capabilities for building accelerated computing applications in the cloud. And so along those lines, you know, just a quick comment on scale. So this is just sort of a quick, you know, history lesson on where we've been with MLPerf on the training side, right? In the early days, I think our first submission, we did about 1,500 GPUs. We then grew that to about 4,300 GPUs. Most recently, we did over 11,000, right? So we're showing not only can we, you know, build at scale, but we can perform very well at scale. What we're very excited about, and again, I'm going to not steal too much of Leo's thunder here, is an announcement today around Supercluster, where Oracle is looking to take that scale and take it out even further. And so, again, I'll sort of tease that a little bit and then let Leo tell you more about that in just a few minutes. So how are customers benefiting from this? Well, I wanted to give you one customer example here. There's a company called Rika who does multimodal LLM models, right? And they wanted to train next generation models both efficiently and at scale. And so what they did is they used over 2,500 of our H100 GPUs to train their models using our Megatron Core framework, as well as using different parallelism techniques to basically get that model trained and then also fine-tuned in a timely manner. And they now make available 3 different multimodal models of different sizes that customers can use on the Oracle platform, right? And so this will be available a little later this month. But what I wanted to do was play for you a short video that sort of shows you what Rika has built in action. So with that, I'm going to click here and show you that video.
Watch long videos in seconds and understand the contents. By asking simple questions to the model, either by talking to it or typing the questions, we can get useful insights from the video, such as generating a detailed summary that captures the essence of the video.
How many people have been infected by monkeypox in the UK in the last 5 months?
Okay, kind of a short video, but it gives you a sense of kind of what Rika is able to do. And again, you know, the models are both intelligent while being fairly compact in terms of LLM size. So this is going to be my last slide, and then I'm going to bring up Leo. We continue to work with Oracle up and down the stack, end to end, to really deliver a great platform for Oracle Cloud customers to get the most out of generative AI, the most out of accelerated computing. We're very excited about what's just around the corner in terms of the work we're doing with Oracle. There was an announcement today where we're going to be basically working with Oracle to build out over time basically a cluster on Blackwell that will take us to zettascale, which is a whole word we don't get to use that often, but it's a very exciting thing. So with that, I'm going to hand it over to Leo to talk to you about Oracle's Oracle solutions that work in conjunction with NVIDIA technology. Leo?
Thanks, everybody, and thanks for joining us today. I hope you're having a great week at Cloud World. So I'm going to talk a little bit about OCI and our AI infrastructure, but primarily around how you can use it to solve some of the solutions and challenges that you're facing today. We're going to talk a little bit about how we help customers build new products, how we help them enrich their ability to do decision making, and how they're able to take the technologies that Dave talked about, as well as some of the stuff I'll talk about, to be able to enhance their applications and workloads that they have today. So one of the key things I do want to land on, though, is that you've probably seen this slide a few times, is that our approach is very much a full stack approach. Part of it is the partnership with NVIDIA to be able to take the amazing technologies that they develop and incorporate it into OCI, but also to take that infrastructure and the services and the data services that we have and make them available through the application layer as well. And the goal there really is, no matter what level you want to consume AI at or those capabilities, you're able to do it without necessarily having to know how to develop software, how to deal with infrastructure or hardware, but still be able to get the capabilities you're looking for and solve the use cases that you're approaching. A little bit more detail, and this is just to illustrate that we have a very comprehensive set of services and infrastructure. I'll primarily be focusing on the infrastructure, but really for most of the use cases you're looking for, whether you're looking to take the data that you have and be able to take that context, take that intelligence and join it with your AI capabilities securely, or again, if you're just trying to solve use cases in finance or human resources or in industry, we're able to support many, many of those use cases and needs. So a little bit more about the infrastructure. Some of the key things, again, that Dave highlighted, we're taking some of that really amazing technology and packaging it in a few different ways. But we also bring a lot of our own experience when it comes to hardware, when it comes to infrastructure, when it comes to networking, to the equation as well. And we're continuing to innovate, whether it's our compute, our networking, and as Dave said, we made some announcements today around just massive, massive clusters that we're building. So first and foremost, bare metal infrastructure. So why is that important? We think it's very, very critical for these types of workloads for customers to be able to get all the processing power that Dave talked about, all the innovation that continues to happen there in the most seamless way possible, where all the resources are provided to the customer as opposed to having some overhead for our management capabilities. So bare metal is really important there. In addition to just offering one type of bare metal, we're taking again, a whole range of different technologies and making that available as a service, whether it's a single instance or across massive clusters of hundreds or thousands of machines. Right? So ultimately, it's about getting the maximum amount of performance and capability so that you can do what you need to do. Second aspect is around networking. So we've actually been doing cluster networking for decades in different products across our portfolio, including our database products, and in a product called Exadata, which then is purchasable or usable in a number of different ways, whether you're talking about the appliance form factor, you're talking about our cloud customer, where we're deploying the appliance and managing it for you on premises, or our database services, which are available based on that infrastructure in our cloud, and now you've seen across all the other hyperscalers where you'll be able to get that capability in the context of a Microsoft or a Google, and very soon within AWS. All right, so to kind of sum it up, we're taking the amazing processing technology, some of the networking technologies, the software technologies that NVIDIA develops, we're packaging it together into compute instances, into our cluster networking, and then with some really, really nice benefits around the price performance, around the scalability, and around some things that are not on this slide, the manageability, right? So one of the key things that we've learned building these massive, massive clusters for customers is the ability to really keep them up, right? Because they are expensive. So being able to keep them up as highly available as possible, even at massive, massive scale, 5,000 GPUs, 10,000 GPUs, all that insight that we're deriving, we apply into our services, so APIs to do monitoring, management, et cetera, and then we also feed that knowledge back to NVIDIA, our partner, to be able to do some additional optimizations in their software and networking, et cetera, to continue to improve the overall product. Some of our current offerings, again, we have a whole range from the smaller instances based on the A10s, including bare metal and virtual machines, into the A100 and H100 based machines, as well as the brand new OCI compute based on the L40S. I'll be showing some of the use cases around that shortly, but a pretty broad product line that's available today. But we're expanding that over time, right? So this is one of the cool things about the market is that it's evolving very, very quickly. And part of our value proposition is instead of you having to figure out which one of these processors, what kind of configuration or architecture you need, we're going to be packaging it up for you so that you, again, can consume these as services so that we're taking that analysis and providing you with the best results. So into the use cases. So first one is all about building, right? And there's a bunch of these customers and partners here today and through the week. If you haven't been yet, I encourage you to go to the Data and AI Pavilion. There's about a dozen of these customers there, and just the whole gamut of things that are being done in the AI and Gen AI space right now is pretty amazing. I won't be able to do it justice, but I encourage you to go there and check it out. But what we bring to the table is, of course, the infrastructure to be able to take one or hundreds or thousands of GPUs and be able to apply it to these new models that these companies are developing and training, right? At this point, there's well over 1,000 models in the market, and that's going to continue to grow. And our goal here is to supply those customers and partners with the infrastructure they need. If they need additional capabilities, we provide them as well. Part of our AI infrastructure also, of course, includes storage technologies, whether it's high-performance file storage or our upcoming clustered file storage based on Lustre, all the types of storage that you need for checkpointing or storing the data. And then into the software and framework stack, great partnership, of course, with NVIDIA and other third parties to provide capabilities, of course, like CUDA, or services like DGX Cloud that NVIDIA offers, where, again, it starts to manage more of the services for you, so you can, again, focus a little bit more on the development of your products. So dozens and dozens of innovators that are here on the show floor, so I encourage you to check it out. Enriching decision making. So this comes in a lot of different ways, right? So most of the customers I talk to are thinking about, okay, how do I take my information? How do I take my data and be able to leverage it with AI in a secure, controlled way? And in some cases, in certain countries, how do I take the data, how do I build the AI in a controlled way so I'm able to meet compliance or sovereignty requirements? So again, lots and lots of different types of use cases here. I'm going to spend probably the most time on simulations and improving some decision making, but as you can see here, this ranges from individual companies that are trying to get infrastructure as workstations to be able to do drug simulations or drug discovery, all the way up into model building and simulations. We provide a bunch of different solutions for all these use cases. Again, when you look at the stack, it's again pretty cool what companies like NVIDIA are able to provide, not just the infrastructure, but in this case, a product called Omniverse that is all about digital twins and creating simulations. So again, we're able to bring a number of capabilities to the situation. If you haven't seen our data management capabilities, a huge slew of innovation there to be able to take your data, whether it's an Oracle database or a HeatWave database, and be able to keep the data in place and be able to perform a number of different operations on it, whether it's for processing, whether it's connecting it to an LLM. Trying to keep the data in place is part of the whole sovereignty strategy, where you don't have to move the data from service to service, from location to location, et cetera, where you start to lose control over that data or the security posture becomes more difficult. By keeping it in one place, it actually addresses part of the need around sovereignty and compliance, which is really having control over the data, who has access to it, the location of it, who can process it, et cetera. So that part of the stack is pretty important as well. So we have what we call a distributed cloud strategy, right? So you've probably seen a few times this week. At this point, we have between live and planned regions, 162 regions around the world. And that includes clouds that we operate, where Oracle is operating it in various countries, where any customer can come and use the services, to more controlled regions, either for government or for specific entities like the European Union, where we're running the infrastructure, but there's different amounts of controls that are applied. So for example, with the governments, all the personnel that are operating those environments are cleared by the US government or the UK government or the Australian government. With the EU Sovereign Cloud, again, specific personnel are actually operating those environments that are EU-based citizens, and even the organization that owns the hardware in the data centers is EU-based and actually has a set of bylaws that's separated from Oracle, right? Because one of the primary concerns of other nations is who has access into my cloud environment, right? So being able to create that separation from the cloud provider is really, really important to try to meet the regulations of the EU. We can go even further where we can deploy our cloud into the customer data center or a partner data center. Okay, so again, this is not an approach where we're shipping a bunch of servers and having the customer figure out the integration of the software and the cloud services, but we're actually bringing the entire solution, the hardware, the services, the cloud services, managing that environment in the customer premises with our dedicated region, or managing it in the partner environment with our Alloy, so that they can take advantage of the entire stack I showed, infrastructure, services, applications, and provide them to their end users or end customers. Okay, so if you can imagine those different degrees of control, that again addresses the different levels of compliance and sovereignty, typically at the foundational level, where you have control over the data itself and the metadata, staying within a region, for example. You have control over who has access to that information in order to see it or process it. And even when you get to the stage of the generated data from Gen AI, again, control over where that data is placed and stored. So very, very broad range of capabilities from an infrastructure level capability that meets a lot of the compliance regulations today. And because we're addressing it from a foundational level, we think it'll support the rapidly evolving kinds of regulations around it as well. Okay, so I'm going to walk through a quick demo of climate simulation. All right, so I woke up today, and unfortunately, I was like, is there something burning in my room? And fortunately, it was not the case. But climate change is a very real thing, right? So if you didn't know, there's a bunch of forest fires happening in California, and that's what you're smelling in Las Vegas. And it's an environmental issue, but it's also a national issue and a sovereign issue for different countries, right? So what we did with this demo is we're showing a bunch of different technologies to enable a customer like a government to be able to use this technology, start to simulate some of these potential climate impact changes, keep it within their borders, the information if they want, and to use it to impact the way they deal with it. All right, so if we can play the demo, please. Okay, so what this is showing is a combination of technology, in this case, a Japanese island, where we're first creating a digital twin, okay, of the island, but also the buildings and infrastructure. Okay, and then we're actually mapping, in this case, the floods of 2020 to show the impact on that digital twin. And you can see pretty soon the brownish red is where the parts of the city are flooded. Okay, and now we're simulating an extreme rain event, okay, and how that's going to affect the infrastructure and the vulnerable parts of it. And this one is a future simulation of water level rise in 100 years, and again, the potential impact to the city. Okay, so that's pulling together a number of different technologies. It's pulling together Omniverse to do the mapping. It's pulling together this company called RSS Hydro to be able to do the flood simulations, all running on OCI with our compute instances with the L40S, which have additional graphics capabilities like ray tracing, et cetera. And the goal, again, is to be able to provide these types of services for use cases like this in a way where an organization or a government can use it either openly and commercially or constrain it down to their specific country or government. Okay, I think I covered that. Another great example, we released this story today, is a company called Wide Labs. Again, a good example of using AI and controlling it. They have a really, really cool application of it where they've developed an LLM that is trained in Portuguese. They keep it and run it within our regions in Brazil because they want to preserve the control over it. But the application of it is really cool because it's all about trying to help patients with Alzheimer's, taking their personal histories as part of the data, and then providing that story back to help them retain some of those memories, right? And obviously there's some privacy involved there as well. So they're choosing to use OCI because of the ability to control that data, because of the ability to run those models inside of Brazil. Okay, last area I'm going to talk about is around enhancing existing products. So we have a lot of customers that are in the tech space, that are in the software space, or just pure AI types of products. And again, they come with a lot of different ranges of capabilities. So again, our goal is to service their needs depending on where they are, depending on their level of skill and expertise, whether they just want the infrastructure and they're bringing their own software, their own models, own technologies, or they need more. Again, some cool things we're doing with NVIDIA around, for example, their NIM microservices or Triton that are focused on inferencing capabilities in microservices. And we have a number of customers that are using a combination of those technologies with our infrastructure. A really nice example is a company called SoundHound, where I like this example because it's very much an enterprise business type of example. It's also an example of some aspects of Oracle's capabilities as well as SoundHound's specific capabilities. So they do a bunch of audio work for a number of different applications, including in retail, in fast food. So I'm going to play a demo here.
The biggest impact SoundHound's voice assistant has had on Chicken Shack would be efficiency. If you can make your business more efficient and utilize your resources in the best possible manner, that's a game changer. I'm Vice President of Detroit's original Chicken Shack. I've been with the business my whole life. A lot of our restaurants were experiencing issues with labor shortages, and so we thought, what can we do as a franchisor to make their lives easier? Prior to SoundHound, our employees would be scrambling to answer the phones and help the guests in store, and they were very fragmented.
SoundHound Voice AI answers 100% of calls, and it helps the staff. They don't get interrupted, people aren't put on hold, so it really helps the restaurant just function more efficiently, and we answer multiple calls simultaneously, so customers never get a busy signal.
It's pretty easy on our end. The order gets taken from the customer.
Thank you for calling Detroit's original Chicken Shack located at 30402 Woodward Avenue. What can I get started for you today?
On the POS system, an alert message comes up. It says a new order has arrived. The order then gets printed off at the printer, and our staff then takes that order and puts it on the rail. Our staff makes the food, we package the meal, and then we place it on the counter for customer pickup. The customer comes in, picks up the food, they're happy, it's a win-win.
The technology was pretty slick. It sent me a text and took the payment immediately, so I was able just to get in, get my order, and get out. It's about the fastest transaction you'll have.
It's made our employees' lives a lot easier and a lot more manageable.
When the phone's not ringing off the hook, it's a lot less stressful environment.
It's really helping us to get orders out a lot quicker because we don't have to stop answer the phone. We don't have to place people on hold if there's walk-in orders.
As a chain, we're looking to grow Detroit's original Chicken Shack throughout Michigan and beyond. And so we feel that this technology offers us some key leverage that new franchisees might be excited about. Because when they're investing in a brand, they want to see where we can grow. And really this offers us the scalability of, if we want to open a store in Michigan or Texas or Ohio, we can do that and it'll have the same experience with the voice ordering technology. We chose SoundHound AI because they're a leader in the AI technology space. They're constantly looking for ways to better their product, such as offering suggestive selling, franchisee dashboards, and these are things that are important to us at Chicken Shack.
Awesome. So how many people in the crowd have seen the show The Bear? A few people? Yeah, they could have used this system. So what I love about this example is that, again, one of it is our partner, SoundHound, that's actually building this technology and making it available for customers. But we've also integrated their technology with our food and beverage applications. So if the customer also needs a point of sale system and all of that, they can buy that whole package, all running on top of OCI, right? So again, a combination of different solutions based on where the customer need is. This is just a quick picture, but again, we have a wide range of customers. I mean, SoundHound is handling hundreds of millions of requests a month, billions over the course of a year. So they need a massive infrastructure to be able to handle all the inference that needs to happen. But we can scale it down to much smaller types of use cases, whether it's internal or non-consumer retail types of use cases. So a broad range of technologies and solutions there. All right, with that, I'm going to bring Dave back on stage. I think the big thing that we want to emphasize is that we've got a whole combination of capabilities and solutions that we've partnered on to support a wide range of requirements. It is a full stack partnership across the hardware as well as the software, and we're continuing to innovate there. Dave and I are on the phone quite a bit because there's all these new things that we're trying to roll out.
Indeed, yeah. We continue to work together on so many things. Again, as Leo touched on the infra, but some of the interesting demos we're doing around database, I think, are really exciting to bring the data in Oracle databases to generative AI. We would very much encourage you to swing by our Data and AI Pavilion, see some of the demos, talk to people, and learn more. And please do visit both, the OCI website as well as NVIDIA sites to learn more about the technologies we continue to work on and innovate and continue to bring to market.
Great. Thank you so much, and we'll stay behind for any additional questions.